Are you confident in your spreadsheets? Are you sure that your numbers are correct? Today, I'm glad to present you a tool called Spreadsheet Verificator. It detects possible hidden errors in your spreadsheets and thus helps you ensure the correctness of your spreadsheets. Spreadsheets are error-prone. A spreadsheet holds important business information, data, and calculation, but they can be dispersed in different ranges and sheets. Spreadsheets can be big and complex. They can be modified by other colleagues. Spreadsheets are hard to review thoroughly. Therefore, you may have heard spreadsheet horror stories where spreadsheet errors caused economic and financial loss and damaged the reputation of the company or organization. We could cite the recent one with COVID-19, where nearly 1,600 COVID-19 cases in spreadsheets went unreported in England, and the one with the Harvard professor, where the spreadsheet leading to her famous research result was proved wrong several years after the publication, and the one with $6 billion trading loss of JP Morgan Chase, where bad spreadsheet management was involved. Facing spreadsheet errors, spreadsheet software makers and third-party companies build automatic tools to detect flaws in spreadsheets. For example, in Excel, we could set up these error-checking rules. As a result, some kinds of defects are flagged in Excel by this green triangle on top left corner of a cell. Additionally, we often see explicit error values such as hash value exclamation mark, hash name question mark in cells. There are lots of tools of audit and verification made by third-party companies. We could cite products of Incisiv, Excel Audit of Simcon, Excel Analyzer of Spreadsheet Software, Operace Analysis Kit, etc. These tools often undertake a dynamic analysis and syntactic checking. However, one widely used and efficient technique of verification of programs is not used. That is type checking. Type checking consists in enforcing the constraints of types and finding flaws by type mismatches in programs. It is very efficient and almost a must in lots of programming languages. Today, I will show you Spreadsheet Verificator, a tool based on type checking in spreadsheets, and show you that it could indeed detect hidden errors in spreadsheets that other tools couldn't find. Let's first recall by some examples how Excel deals with types. Let's check equals quotation mark ABC quotation mark plus 123. It returns hash value exclamation mark. Excel realized that it's absurd to add ABC to 123. Thus, Excel returns an explicit error value. That's what we expected. Let's check equals quotation mark ABC quotation mark greater than 123, which is an absurd operation too, because it doesn't make sense to compare a string to a number. We would expect that an error could be raised as the previous example. However, surprisingly, Excel returns a value true rather than explicit errors like hash value exclamation mark. We could try equals quotation mark 1 quotation mark greater than 123. It also returns true. Actually, this is because Excel considers that a string is always greater than a number. This logic doesn't make sense nonetheless. Similarly, let's try equals true greater than 123 and equals false greater than 123. In other programming languages, it would either raise an error or returns false if true is converted to 1 and false is converted to 0. However, in Excel, both of them return true. That's because Excel considers that a Boolean is always greater than a number. This logic doesn't make sense. Let's try equals today times 2. A product of a date and a number would raise an error in other programming languages. By contrast, Excel returns an odd number. To sum up, Excel has a weak type system. Absurd operations with regards to types don't always raise explicit errors. Data can be automatically and silently converted to other types, but rules of conversion are not clear or make sense. Operations with type mismatches may return wrong or unexpected results. Type checking tool could indeed help improve safety in such a system. Precisely catching the operations with type mismatches could first identify wrong results in Excel. More importantly, those operations are often not made intentionally. Such operations are produced often because there is something wrong upstream in a spreadsheet. Once such operations are identified, they could be clue or trace about what you did wrong upstream. Now let's demonstrate Spreadsheet Verificator, which is actually a functionality in the TenStudio toolset. Let's get started. Go to the Insert menu, then Get Add-ins. Here is the store of Office add-ins. In the search bar, type TenStudio, enter. Click on Add to add it to your Excel. Agree to all the above terms and conditions. Continue. Here you see a menu TenStudio. Then there is a button Spreadsheet Verificator. Click on that. On the right-hand side, you can see a task pane. In the task pane, there is just one button, Verify the workbook by types. Let's click on that. Then the verificator undertakes the type checking. As you could see, all the formulas that contain type mismatches are identified. For instance, there is a comparison of string and integer. There is a comparison of Boolean and integer. We could click on that to go to the problematic cell. Now let's take a look at an example where an operation with type mismatches is an intentional effect of a problem upstream in the spreadsheet. Once Spreadsheet Verificator has identified this operation, it could be clue about the problem upstream. Let's see this example. Here we have a formula which finds out the score of Amber, then checks if it is greater than 300. If it is, then it is a good score. Otherwise, it's not a good score. We see that because Amber's score is 50, it's not good enough. The cell value is false. Now, if we insert a column here, the spreadsheet doesn't raise any error. But if we check it by the add-in Spreadsheet Verificator, it identifies a meaningless operation with regard to types. We have a comparison of string and integer here. Now from this warning, we investigate how this operation with type mismatches is produced. It is because after inserting the column, the value returned by the VLOOKUP function is not 50 anymore. It is LI now. This is a behavior of formulas with VLOOKUP that many people are not aware of. People thought the formula would auto-adjust to keep the correct result following the insertion, but actually it doesn't. As a consequence, we are comparing now Li to 300, which silently returns false, which is not correct at all. To sum up, or manipulation of inserting a column broke the spreadsheet, but Excel didn't raise any error. By contrast, Spreadsheet Verificator detected type mismatches that this problematic manipulation resulted in and gave us a useful warning. VBA language has a weak type system too. Spreadsheets having formulas and VBA macros are even more error-prone than spreadsheets having formulas alone. Type checking of spreadsheet applications with VBA macros is indeed an effective way of detecting flaws, but it is a difficult task because VBA macros could be very complex. Spreadsheet Verificator is powered by a full analyzer that we implement for spreadsheet applications having formulas and VBA. To analyze VBA macros, we undertake static analysis by abstract interpretation, which is traditionally used to analyze imperative programs like C and Java. Let's show a real-world spreadsheet where Spreadsheet Verificator detected an error by type checking. By the way, as the web add-in doesn't have access to VBA macros, we used the desktop version of Spreadsheet Verificator. In this workbook, the subroutine doAssign uses a nested loop to copy a table of basic parameters into another sheet where biological simulations are performed. Spreadsheet Verificator detected that the whole zone of the table was double except the first line, which was empty. However, this zone had been assigned to a double zone in another spreadsheet. Upon investigation, we noticed a one-line shift between the source table and the target table because the range of the loop was wrong. This will result in the target table being incorrectly filled in, its first line filled in with 0, the copy result of empty cells. And the simulations based on these parameters will generate incorrect results. Now let's talk a little bit about why Spreadsheet Verificator could detect hidden errors that other tools couldn't find, and the technologies behind the tool. To ensure the correctness of the verification, unlike those tools that undertake a syntactic analysis, Spreadsheet Verificator undertakes a semantic analysis. It infers and verifies types in formulas of cells and ranges following the evaluation order of a spreadsheet. Then Spreadsheet Verificator is the only one tool that deals with VBA programs. VBA programs can have variables and contain loops, functions, and procedures. They can be very complex. To analyze VBA programs, we implement a parser of VBA programs and use a technology called abstract interpretation, which is traditionally used to analyze C programs and Java programs. Additionally, besides dynamic analysis that most of the tools undertake, Spreadsheet Verificator also enables static analysis. While dynamic analysis only looks at the current instance of a spreadsheet, static analysis examines all possible execution paths and variable values of inputs of a spreadsheet application, and ensures the spreadsheet application is exempt from a certain class of errors. Spreadsheet Verificator consists in applying dynamic analysis and static analysis by type checking and abstract interpretation, which is solid and rich academic research to spreadsheet applications. We especially developed the Spreadsheet Verificator and its core analyzer for spreadsheets and VBA macros in INRIA during my PhD. From the same core analyzer, we derived and developed several tools to examine different properties of a spreadsheet application. We present the core analyzer in another video.